Hello student, in this video I am going to solve exercise 6.5 questions from NCERT textbook. So let us begin. On our question number 5. ABC is an isosceles triangle with AC equal to BC if AB square equal to 2AC square. Prove that ABC is a right angle triangle. So here we have given a triangle ABC isosceles. This is isosceles. So now draw and figure. This is a triangle, isosceles triangle. As we know, isosceles triangle having two sides are equal, such that AC, suppose this is AC and BC. BC. This is AC and BC are equal, and if AB square equal to AC square is given, then to prove ABC is a right angle triangle. So given this is AB square equal to AC square, and this can be written AC square, right? And here given AC equal to BC, then AC we can write AC square equal to AC plus AC BC. We have given AC equal to BC. Here we will find AB square equal to AC square, BC square. So this is the Pythagoras theorem. Okay, Pythagoras theorem. AB square equal to AC square, BC square. So now we can say triangle ABC is a right angle triangle. Triangle ABC is a right triangle. So this is the proof. Now move to the question number 6. ABC is an equilateral triangle of side 2A. Find each of its altitude. Okay. So here we need to find each altitude. So now what are doing over here? First, draw a triangle ABC, equilateral triangle. This is equilateral triangle. A, B, C, having side to A. This is side to A. And now let us draw altitude at A on BC. So this is a equilateral triangle ABC, and AD is altitude from A on BC, and we have to show find each altitude in this question. Find its altitude. Okay, so as we know, altitude, draw the altitude bisect the opposite side. Okay, so here this is altitude, and now bisect this side BC. So total length is 2a, then after draw AD altitude, this will be divided into A and A. Total 2a divide A and A. So now write here we know altitude divide altitude bisect the opposite sides. Okay, so here BD equal to BC equal to A. Okay, and now in triangle ABB triangle ABD, right angle at D, equal to 90 degree. Now applying Pythagoras theorem. So we obtain this is AB square, AB is hypotenuse, equal to BD square plus AD square. Here we have the side AB equal to 2A, so this is 2A square equal to BD. BD is A square plus B square, and now simplify. So this is 4A square equal to A square, AD square. This implies AD square equal to B square, and AD equal to A root 3. This is the altitude AD equal to A root 3, and as we know, in equilateral triangle all altitudes are equal in length. Okay, all altitudes in equilateral triangle, all altitudes are equal in length. So therefore each altitude equal to Okay, so this is the answer of this question. Further move to the question number 7. In this question, we have to given prove that sum of the square of the sides of a rhombus is equal to the sum of the square of its diagonal. Okay, means we have to given an rhombus, and to prove the square of their sides, sum of their side is equal to the sum of the square of diagonal. Okay, so to prove this, now first let us draw an figure of rhombus. So this is the figure of rhombus. Suppose this is A, B, C and D, and their diagonal bisect each other at O. Okay, so this is the rhombus inside AB, BC, CD and DA, and diagonal AC and BD is which intersect at point O. Okay, and then after draw diagonal of rhombus AB BC, we divide. Okay, then we see four part of triangle. Okay, here. Okay, and as you also know, the property of rhombus is diagonal. Its diagonal bisect to each other at 90 degrees. So here we make 90. Okay, so AB square side BC square CD square plus BA square equal to diagonal AC square and BD square. Okay, so now consider triangle AOB. In triangle AOB, applying Pythagoras theorem. So this is applying Pythagoras theorem. So we will get AB square equal to OA square plus OB square. Say equation number 2, and similarly in equation D in triangle BOC, this is BC square equal to OB square plus OC square. This is equation number 2, and in the triangle COD, CD square equal to OC square plus D square, equation 3rd, and in last triangle AOD, in triangle AOD, AD square equal to OA square, OD square, OA square and OD square. And now here we have to prove AB square plus BC square plus CD square plus DD square equal to AC square plus BD square. So now we are here adding equation 1, 2, 3 and 4. Adding 1 plus 2 plus 3 plus 4. So we will get this is AB square, BC square, CD square, BA square equal to OA square, one here and other here. So this is 2 OA square and same OB square and here OB square, 2 OB square. So now taking common, so we will get OA square, OB square, OC square and OD square. And now here OA and OB, and this is OC and OD. And as you know, the diagonals bisect to each other. So therefore here 2 and OA equal to AC by 2 plus OB equal to BD by 2 square plus OC again, this is AC by 2 whole square plus, and OD, this is BD by 2 whole square. And now here this is 2 and this is AC square by 4 plus AC square by 4. Okay, so AC square by 4, AC square 4, 2 AC square by 4 and divide, so you will get AC square by 2 plus, and this is BD square by 2. Now taking 2 here as common, so 2 into 1 by 2 to cancel, so finally we will get AC square plus BD square. So this is AB square, BC square, CD square plus DA square equal to AC square, BD square. So here we have to prove the sum of the square of the sides is equal to the sum of the square of their diagonals. Okay. Now move to the question number 8 of exercise 6.5. In this question, we have given in figure O is a point in the interior of a triangle ABC. OD perpendicular on BC, OE perpendicular on AC, and OF perpendicular on AB. So that the first part we have OL square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus CE square. And second part is given AF square plus BD square plus CE square equal to AE square plus CD square plus BF square. And here alongside given the figure, this is triangle ABC, and we have given some more figure. Here OD is perpendicular on BC and OF is perpendicular and OE is perpendicular on AC. And here first we need to show this OA square plus OB plus OC square minus OD, OE square minus OF equal to AF plus BD square plus CE square. So now check this OA, OB, OC and OD, OE, OF, AF, BD and CE, which is the part of the triangle. So this is OA. Okay, so now let us first draw O to A to O, join A to O, and here OB, then O to B and OC, from again O to C. This is point 2. Okay, so here required AF, this is AF, and BD and CF. Okay, so this triangle and this triangle and this triangle are required. So first join OE, OB line Pythagoras applying Pythagoras theorem. In triangle AOF, so this is OA square equal to AF square plus OF square. Say question one. And similarly in triangle BOD, OB square equal to BD square plus OD square. Say equation 2. And similarly in triangle COE, we obtain OC square equal to OE square plus CE square, OE square plus CE square. Say equation 3. And now here we have to prove OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus C square. So what we have to do from here? So we will adding equation 1 and 2. In short, adding plus OC square equal to on right side AF square plus OF square plus BD square plus OD square plus OE square plus CE square. And shifting the term OE square and OF square on left side, so this become OA square plus OB square plus OC square minus minus OD plus OD become minus OD square and minus OE square minus OF square equal to AF square plus BD square plus CE square. Okay, so here this is the proof of first part. Okay, OA square OB square plus OC square minus OE square minus OE square minus OF square equal to AF square plus BD square plus CE square. And second we have to prove AF square plus BD square plus CE square equal to AF square plus CE square plus BF square. So now from the first result, this can be written as this is AF square plus BD square plus CE square equal to this can be written OA square minus OA square minus OE square plus OB square combining OA square minus OE square and OB square OB square minus OF. This is OF square plus next OC square minus OC square minus OE and OD square. This is OD square. Okay. Now look at OA square. OA square OE square is equal to A square. So this is AE square by Pythagoras theorem and OB square square plus OF this equal to BF square. Okay, equal to B square plus and next OC square OD square equal to CD square. This triangle CD square. So finally here we will get AB square plus BD square equal to plus BF CD square plus BF square. So this is the proof of second part.